Welcome to our foundation channel. From class 9th mathematics, the chapter number 8 is logarithms. So in this chapter, I'll see first what is the logarithm definition and some basics, the main properties of the logarithms, let us see here, and interchanging one form to other form. Okay, and laws of logarithms. So what are the laws are there? How to apply in the problems I'll explain. And expansion of expressions. So with the laws of logarithms. After learning this all the laws, so based on that how to apply the problems, those all let me explain here. And some more about logarithms, other problems, the basic based on these concepts I'll explain each and everything one by one. So those are watching the first time, you can subscribe to our channel and follow the content in order. So chapter wise I'm showing. So you can see the link in description below about the material also, you can find out there. Right. So let us begin the topic now. Logarithms, actually the main concepts, the basics only they are introducing in this class 9th, and the complete information you can find in higher level, higher classes. So according to our syllabus, we have only the basics of logarithms, the definition, few laws of logarithms and their problems. Right. So logarithms are used to make the long and complicated calculations too easy. So any huge calculations, complicated calculations, we'll use this logarithm concept to do the calculations simple and easy. Right. First of all, let us see some exponential form. We know 3 to the power 2, that is 9, because 3 power 2 is 3 should be multiplied 2 times. 3 into 3, 9. And 4 to the power 3. So 4 should be multiplied 3 times. 4 4 is 16, 16 4 is 64. That means 4 to the power 3 is 64. So this is a exponential form. 3 power 2 is 9, 4 power 3 is 64. So again 3 to the power 4 is 81. So these all come under exponential form. Now this exponential form, how to convert into logarithmic form? So exponential form already we know, expansions we studied. Now this one you have to convert into logarithmic form. For example, 3 to the power 4 is 81, right? This is in exponential form. In logarithmic form, you just use the word log, log. Instead of writing full logarithm, write log. Log 81 to the base 3 is equals to 4. So this is the exponential form to logarithmic form conversion. So let us take one generalized formula, like a to the power b is equals to c. Right? This is in exponential form. To convert into logarithmic form, just write the log word. Here a is the base and b is the power. So base is a, right? So same base a only can keep here. For log also to the base a. Next, here is the equal symbol. This b and c, the places will be changed. You observe the pattern. So it must be c and this is b. So this is log c to the base a is equals to b. Same, any number is existed, we can write in logarithmic form in this type. So this is the main important thing to converting from exponential form to logarithmic form. Again logarithmic form to exponential form. So only these two you can notice. Here is the base is 3, right? Same base 3. Now these both are just changing their places. To remember you, just I am showing like this. The main thing is the formula is if a power b is equal to c, then in logarithmic form is log c to the base a is equals to b. Here is a, b, c are three real numbers and a is not equals to 1. A is not equal to 1 in this case, and a power b is equal to c. So b is called the logarithm of c at the base a and is written as like this, log c to the base a is equals to b, right? And logarithmic form to exponential form, the conversion and including the problems we will see now. Interchanging, so logarithmic form to exponential form, again exponential form to logarithmic form. So as I explained just now, if a to the power b is equals to c, right? So this is called exponential form. So is called, now this is in exponential, it's called in exponential form. Now same thing in logarithmic form, and here is log to the base a is as it is. So log c to the base a is equals to b. So this is called in logarithmic form. Yes. So this is the conversion. Now we can take any example. Let's take 2 to the power minus 3 is equals to 0.125. Okay, this is an exponential form. 2 to the power negative 3 is equal to 0.125, and 4 to the power 2 is equal to 16. So these are exponential form. To convert into logarithmic form, we should keep the log word to the base 2. So same 2 you can keep. And here value is 0.125, that is equals to minus 3. So log 0.125 to the base 2 is minus 3. Here is the log 16 to the base 4 is equals to 2. Just remember the same base 2 and 16. So 16 and 2 equal sign. Just converting exponential form to logarithmic and logarithmic form to exponential form. So log of 8 to the base 64. So 64 to the power 1 by 2 is equals to 8. Even to the power expansion set, even though you can make 64 to the power 1 by 2 is equal to 8. So converting into logarithmic form, base is 64. No, keep the base 64. Just log 8 to the base 64 is equals to 1 by 2. Right? This you can write. Even though same way, you can make generalize some formulas like x to the power 0 is equals to 1. So is x is non-zero, any number to the power 0 is 1. If you convert into logarithmic form, log same to the base x, 0 and 1, no, 1 and 0. That means log 1 to the base x is equal to 0. So log of 1 to the base x is equal to 0. In general, we can say the logarithm of 1 in any base is nothing but 0. Right? And x to the power 1 is equal to x. Right? This you can convert into logarithmic form. So log to the base x as it is, this 1 and x, no, x here, 1 here, change. So log x to the base x is equal to 1. These two we can make as generalize. Log of 1 to any base, the value is 0. Log x to the base x, value and base are same, the answer is 1. Right? Let us see problems based on in this one by one. Here is a question. See here. The logarithm of 1000 to the base 10. So first one, log 1000 to the base 10. Value you have to find out, let be x. Now x value is supposed to calculate. Now this is the logarithmic form. Convert into exponential form. Same base, no? So to the power x is equals to 1000. This 1000 and x, just change the places. Converting exponential form. From this 10 to the power x is equal to 1000, we can write 10 to the power 3. When base is same, we can equate the powers. So x is equal to 3. X is 3 is nothing but this. Therefore, log 1000 to the base 10 is equal to 3. So this value is 3. Same way, second one. Logarithm of 1 by 9 to the base 3. So log 1 by 9 to the base 3 value. Let be x. Logarithmic form to convert into exponential form, then only we can simplify to find out x value. So that is same base 3. So 3 to the power x is equals to 1 by 9. 1 by 9 I can add 1 by 3 square. That is 3 to the power minus 2. So base is same, right? So equate the powers. X is equals to minus 2. Therefore, so we can conclude. Therefore, the log 1 by 9 to the base 3 is equals to minus 2. Right? This is one. The not mentioned, you can take it as x and solve. And see these questions. If already given values, same. Converting form, logarithm form to exponential form. Here is log x to the base 2 is minus 2. So 2 to the power minus 2 is equal to x. Okay, 2 is the base. X and minus 2. So minus 2 is power and x. 2 to the power minus 2. So x is equals to 1 by 2 to the power plus 2. So x is equals to 1 by 4. Right. Same way. Second one. Log x plus 3 to the base 4 is equal to 2. So 4 to the power 2 is equal to x plus 3. This is 4 to the power 2 is equal to x plus 3. Then 16 is equals to x plus 3. Then x is equal to 16 minus 3. X is equals to 13. 13 is the value. Same with third one. Log 64 to the base x is equal to 3 by 2. That is x to the power 3 by 2 is equal to 64. Right? X to the power 3 by 2. So to remove this 3 by 2, whole to the power 2 by 3. You can make it. So x to the power 3 by 2 is there. This side 64 is there. So 3 by 2 you take other side. You can whole to the power 2 by 3, whole to the power 2 by 3. Reciprocal of this you can do, because 3 by 2 into 2 by 3 is 3 3 cancel, 2 2 cancel, only x will get. 64 to the power 2 by 3. 64 you can write 4 cube, whole to the power 2 by 3, 3 3 cancel, 4 square, that is 16. Right? So this value is equals to 16 from this x value. From this x value is equal to 16. Right. So anything when they're giving a logarithmic form, convert into exponential form, then only we can try to solve the problems base, making like base are same or powers we can make it equal. Base are making same, then powers are equal. If the powers we can make same, then base is equal. Right. Let us see the laws of logarithms and their problems. Laws of logarithm. So we have three important laws to do the problems or to calculations. We can use these three important laws. Let me show you one by one. So let us take first, second, third. So the first law. In laws of logarithm, the first one is the product law. So you can take product. So in this product law, the logarithm of product of any non-zero base is equal to the sum of the logarithm of its factors. Let me show you here. For example, log of m into n. This is equals to log m plus log n. Log of m into n is log m plus log n. So logarithm of product of any non-zero base is equal to sum of the logarithm of its factors. Factors means m into n. So the number, no, this is one of the number. Its factors is mn. So log of mn is log m plus log n to the base. Let us take k is the base. So same base you can apply. So log mn is equal to log m plus log n. So this is the product law. Same way you can extend any extensions like log of m n p. This you can write log m plus again log n plus log p. So whatever the factors are there, product of the factors, we can separate with plus. Okay, this is only the product law. I'll show even examples. This log 12 is asked. So log 12 we can write, if we write 3 into 4. So this we can write log 3 plus log 4. Right? So 12 factors, 3 in 4. So log 3 log plus log 4 we can write. Okay, so this is the product law. Next one, second law. Second law is the quotient. Quotient law. Yes. So when we see this one, this is the multiplication, right? Now is the division. That is log of m divided by n. This is log m minus log n. If the division should be minus, that means the logarithm of fraction at any non-zero base is equal to the difference between the logarithm of numerator minus logarithm of denominators. Numerator minus denominator. Log m by n is log m minus log n. Right. Let us see one example. So log of 125 by 13. So this we can write log 125 minus log 13. So proofs not required as per syllabus, just only see the product law, quotient law, and one more. Third one is, so first and second is clear, right? Just product means you can take with separate with plus. If it is a division, separate with minus. Is only the difference. And next, so in this second one is important to remember, just if it is log m by log n. So this is not equals to log m minus log n. Remember, log of m by n is different, log m divided by log n is different. So this is important note. Log m whole divided by log n is not equal to log m minus log n. Only log of m by n is log m minus log n. Right? And third law in this logarithm, power law. Yes. So in this power law, if you observe, log m to the power n. This we can write n into log m to the base, same way. If it's a is the base, here also a, right? If a is the base and a. Log m to the power n to the base a is equal to n into log m. So what is the power, you can take it as the before the log. The logarithm of power of number at any non-zero base is equal to logarithm of number multiplied by the power. Okay, that log value is multiplying with the power. So n into log m. Let us take example. So log 16. For example, log 16 I can write log 4 to the power 2. 16 is 4 to the power 2, right? This you can write 2 log 4. The power you can make it as the product to the log value. So 2 into log 4. Right. So anything you can use the same type. What is the power, you can make it as front. Like let us take log nth root m. This I can write log m to the power 1 by n. So you can write 1 by n as the power 1 by n and log m. So these are the three important laws of logarithm: product, quotient, and power. This one you can use in the problems. Before that, let me show some basic steps in this. The logarithms to the base 10 are known as common logarithms. If any base is given as 10, this is the common. And in case if there is no any base is not given in the question, you can take it always base as a 10. Separately if they mention, okay, for example this one log 12, not given anything, so you have to assume base is 10. Right, now base is given, take it is always 10. And like log 8, so we can write log 8 to the base 10, log a to the base 10, log 10, so log 10 to the base 10 and so on. And log 1 is 0, log 10 to the base 10 is 1. We starting we saw log 1 value is 0, log x to the base x, same numbers, no 1 will get. And log 100 to the base 10 is 2, because log 100 I can write 10 square. 10 square means power rule, so 2 into log 10 and same base. So log 10 to the base 10 is 1, so 2 into 1, that is 2. Same if it is 1000 you can add 10 power 3, so 3 we can take front. So you can remember log 100 value is 2, log 1000 is 3, log 10,000 is 4, and so on. Right. So these basic steps we'll use in the problems now. So I'll show you the numerical and some word problems based on these logarithms one by one. Expansion of expressions with the help of laws of logarithms. So let us see the question wise one by one. So you can expect the same similar problems in these logarithms to this express any expansion. Right. So the question is, first one, express log fifth root of 108 base 10 in terms of log 2 and log 3 to the base 10. First the value is given. So log fifth root of 108 to the base 10. Base 10 is mentioned, right? You can use the same base 10 throughout the sum. So log, write this fifth root of 108. So 108 to the power 1 by 5 to the base 10. And next one, power rule if you apply, 1 by 5 is the product with this log. Log 108 to the base 10. Now 108 you can use prime factorization method. So 254 and 227, 3 table 9, 3 3 is 3 1 so. This we can write in exponential form. 1 by 5 log 108 2 power 2 3 to the power 3. 2 to the power 2 into 3 to the power 3 is there to the base 10. We can use this next to product rule. So 1 by 5 in the bracket log mn, log m plus log n formula. So log 2 to the power 2 plus log 3 to the power 3 to the base 10. Again you can use 1 by 5. So 2 log 2 to the base 10 plus 3 log 3 to the base 10. Right. So this is the we expressed in terms of log 2 and log 3. Only log 2, log 3 are there. So given expressions, right? Anything is given, convert, just use the product rule, quotient rule and power rule to express to expansion of this any expression. One more question. Previous one we just expanded that. Now this question is opposite. Express as single logarithm. 2 plus 1 by 2 log 9 to the base 10 minus 2 log 5 to the base 10. Right. So here's a total 3 terms. 1, 2, 3. 2 is right. So already we discussed previous. Log 10 to the base 10 is 1 and log 100 to the base 10 is equals to 2. So instead of 2 we can write log 100 to the base 10 in this place because next to 2 are in logarithmic word form. So instead of this 2 we write log 100 to the base 10 plus 1 by 2 log 9 to the base 10 minus 2 log 5 to the base 10. Now this is the 100 log 100 to the base 10 plus 1 by 2 we can write as the power because same power rule you can apply. So log 9 to the power 1 by 2 to the base 10 minus here also log 5 square to the base 10. Before 2 we can write as a 5 power rule you applied. Next if it is a plus which is supposed to multiply, minus is dividing. So log 100 into 9 power 1 by 2 divided by minus means division 5 square to the base 10. This we have to simplify. So log 100 into 9 power 1 by 2 is 3. 5 square is 25 to the base 10. So 25 times 4. 4 3 is a 12. So log 12 to the base 10. So this is in single logarithm. Right. Same product rule, quotient rule and power rule only applied. Plus is product rule. So minus no quotient rule again division. And is a power rule. You can apply to make it a single term. And see one more type of questions. In this type, we have to find out the x value. Starting topic we discussed. First one, log x plus 5 to the base 10 is 1. So convert into exponential form, then find out the value of the x. So exponential form, this is log x plus 5 to the base 10 is equals to 1. Right, in exponential form, 10 to the power 1 is equal to x plus 5. You can take this. From this you can find out the x value directly. So 10 power 1 is 10, then x is equals to 10 minus 5, that x is equals to 5. Right. Second one, log x plus 1 to the base 10 plus log x minus 1 to the base 10. So LHS, that is log of x plus 1 into x minus 1 to the base 10. Log m plus log n, so log mn formula. Same way, log 11 plus 2 log 3. So log 11 plus we can write log 3 whole square to the base 10. Now here is log x plus 1 into x minus 1. So x square minus 1 square to the base 10. This is log 11 into 3 square, that is 9 to the base 10. We can simplify both the sides. So if you eliminate this log, then that means x square minus 1 is equals to 11 into 9, that is 99. X square minus 1 is 99. x square is 100. 100 you can write 10 square. So from this x is equals to 10, right? Plus or minus 10. So you can take the positive value, right? So whenever the log is either side, just don't cancel by removing that. No need to remove, just don't take this values must be same because log is same with the same base. So this value is also equal. Next type of question. This is the finding the value type. If log 2 is given, log 3 value is given. So they're given the question, we just will apply in this. First one, log 6. Log 6 value is not given, but 6 we can write product of this 2 and 3. So log, instead of 6 we will write 2 into 3. Now this is formula, log 2 plus log 3. So product rule, log mn is equal to log m plus log n, right? So just to apply. Now here is log 2 value 0.3010 plus log 3 0.4771. Just by adding we'll get that. So 0.7781. Same way, next one here is second one. Log 5 they mentioned here. So log 5 you take. 5 we can write 10 divided by 2, right? Log 10 divided by 2 because they gave only log 2, log 3 values. Log 10 divided by 2. This is log 10 minus log 2. If there is not given any base, assume there should be 10 is the base. So log 10 to the base 10 is 1 minus log 2 value. So 0.3010. 1 minus 0.3010. So 0.6990. You can take. See this third one also. Is one more. Log root 24. So we can write this is log 24 to the power 1 by 2, right? 1 by 2 you can take front, 1 by 2 into log 24 you can write in expansion form 2 power 3 into 3 power 1. So 1 by 2 you can use this formula, log 2 power 3 plus log 3 power 1. So 1 by 2 that is 3 log 2 plus log 3. You just apply the value. So 1 by 2, 3 into log 2 value plus log 3 value. So here is log 2 is given 0.3010, log 3 value 0.4771. Just to simplify, you'll get the value finally. So 0.69005 will get. Just multiply 3 and add with this number and divide by 2. You'll get this. This is the most problems you can expect from these logarithms, and some more problems also. Let us see now. More about logarithms. So apart from the product rule, quotient rule and power rule, let us see some other concepts in this logarithm and I'll explain the problems also based on this. So already we know 2 to the power 3 is equals to 8, right? This is in logarithmic form. Log 8 to the base 2 is equal to 3, right? And one more, 2 to the power 3 is 8 and 8 to the power 1 by 3 is equals to 2. 8 power 1 by 3 is 2 value. If you convert this into logarithmic form, log 2 to the base 8 is equals to 1 by 3. So if you notice here, log 8 to the base 2 is 3 means log 2 to the base 8 we got 1 by 3. So we can generalize one formula, log a to the base b is equals to 1 by log b to the base a. So if you change their places, it will come to reciprocals. So 1 by log b to the base a. And same way, if it is log b to the base a, so 1 divided by log a to the base b. Okay, this small change we can do it. So we can conclude in this type. Just observe now, log 8 to the base 2, that is equals to 1 divided by log 2 to the base 8. Just change 3 and 1 by 3 reciprocals, right? Same way. Log 8 to the base 2 is equal to 1 by log 2 to the base 8. Okay, this is the rule on this concept we'll apply in these problems. Let us see this question. Here is the question is evaluate log 625 to the base 125 minus log 64 to the base 16. Okay, so this first problem minus it is. So division you can write. So log 625 to the base 125. Log 625 to the base 125. So this we can write. Actually, we have the formula. I'll write here. Log m to the base n. We can write log m and divided by log n to any base. So, for example, if you take a as the base, a we can write log m to the base n is log m whole divided by log n to the base. Same base we can use. And if not mention the base, you can take it as 10. So, in that case, log 625 divided by log 125 it is. Log 625 to the base 125 you can write log 625 by log 125 minus this also log 64 divided by log 16. You can use the same base 10 for everything. Not mentioned, no, take that the base 10. Next, we can write in exponential form. Log 625 is 5 to the power 4 by log 125 is 5 to the power 3 minus log 64 we write 2 to the power 6 by log 16 is 2 to the power 4. We can use the power rule. To use the power rule, 4 you can keep front. So 4 log 5 by this is 3 log 5 minus 6 log 2 by 4 log 2. You can cancel this log 5 log 5 log 2 log 2. Finally 4 divided by 3 minus 3 divided by 2. That is simplify minus 1 by 6 will get. Right? This is the way to evaluate. And one more question. Use the same problem. Log 32 to the base 16. So you can write log 32 divided by log 16. This is the formula you apply. Yes. Minus log 125 whole divided by log 25 plus log 27 by log 9. Yes, now write in exponential form like with power each and everything you can use the prime factorization method. So 32 we can write 2 to the power 5 by log 16, no? So 2 to the power 4 minus same here 125 5 power 3 by log 25 is 5 square plus log 3 cube by this is 9 is log 3 square. Same like previous one, use the power rule. 5 is the power, no? So 5 into log 2 by 4 into log 2 minus this is 3 into log 5 by 2 into log 5 plus 3 log 3 by 2 log 3. Just cancel this log 5 log 5 log 3. Then we got 5 by 4 minus 3 by 2 plus 3 by 2. Here is minus 3 by 2 plus 3 by 2 cancel. 5 by 4 is the answer. That is 1 by 4. Right? This is in evaluate. And similar type one more question. Yeah, see one more last problem. If 1 by log x to the base a plus 1 by log x to the base b is equal to 2 by log x to the base c, we have to prove this one. So previous formula starting we discussed right here. This one. Log a to the base b. You can write 1 by log b to the base a. If we change, this position will be changed. Okay, same thing will apply this logic here. So in this from the given 1 by log x to the base a. 1 by log x to the base a plus 1 divided by log x to the base b is equals to 2 divided by log x to the base c. So log x to the base a, if you take to numerator, becomes log a to the base x, plus this is log b to the base x. This is 2 into log c to the base x, right? Now here log a plus log b, the same base. So log a into b to the base x. Here is 2 is the before the log, we can write as a power for c. So log c square to the base x. Right. So then if you eliminate this log both the sides, just from this AB is equals to c square. So therefore c square is equals to AB. It's only what you have to prove it. So same log base x both the sides. So AB is equal to c square and c square is equals to AB. So hence prove. So you can use the product power quotient rule mainly. Again, this is the reciprocal, changing the place. This formula also you can apply. So most of the logarithm concepts based on these problems only you can notice. And those are watching the first time, you can subscribe to our channel and follow the content in order to learn one by one.